All right, here we go. So we just did in section 1.4, parts A and B of problem 1, and we're going to look at part C together here. So we have approximate solutions for different step sizes using the Euler method, and what we're asked to do is compare it to the exact value. So to find the exact value, let's look at this problem. So we had y prime is equal to t divided by y, and with the initial value of y of 0 is equal to 1. What you'll notice is I could write the right-hand side of the equation in terms of a function of t multiplied by a function of y. So that is what we call a separable equation. So using our skills, we can rewrite this equation as y. Well, let's do it in 2 steps so it doesn't seem too crazy. We can first write it in this differential form, and then sort of the shorthand way of writing these out. And say, well, if we write it that way, again, it's a little hand wave-ish. It always bothers me a little bit, but you know, hey, gets the point across. And we're going to integrate them. So now it's a fine symbol. So what does this become? Well, this gives you, bring it back over here, so y squared over 2 is equal to t squared over 2 plus some constant. And this constant is really what's going to be the issue of finding. So we can do it in 1 or 2 places. We can either decide to solve for it now, or we can solve for C now, or we can mess with Y. If you were to ask me, let's just go ahead and plug in the values now to get C out of the way. So for this problem, let's go ahead and say, well, C will come out if we plug in a 0 for T and a 1 for Y. So plug in a 1 for Y, we get 1/2 on the left. If you go to 0, 1/2 of 0 is still 0, plus C. So C is equal to 1/2. Great. So we can write this as y squared over 2 is equal to t squared over 2 plus 1/2. Or what might be a little bit prettier is to just write that as y squared minus t squared is equal to 1. Okay, so there is a form that we can use. Now, for this one, if we want to use sort of Euler's method, it's really nice to be able to have y solved explicitly. So let's just go ahead and do that real fast. So to solve it explicitly, that means get y by itself. So we can get y is equal to square root of 1 plus t squared. Now you could think, well, plus or minus should really work. That would, make this thing still true. But for our purposes, because we are given the y value being 1, we're really just going to take the positive square root. And then we can plug in our different values for this. So if we want to compare it at the value of 0.2, so y of 0.2 is equal to square root of 1 plus 0.2 squared. So allow me to plug it into my trusty calculator. So the square root of 1 plus 0.2 squared gives us approximately 1.019804, etc. Okay, so here's our solution. Let's see how close we were before. So scrolling up, so think 1.0198. That corresponds to this. 1.0149, so not too bad. 1.01. So 1.01, it's not terrible, but we got a little bit closer when our step size was smaller, which is normally the case. But here we're able to find out the exact solution was 1.019804. Now if we have to calculate things like error, you can just subtract your approximate solution from this, and you can sort of see how far off you were.